the only design pattern that I expect you to have seen before is Iterator. Although nobody might have told you that it is a design pattern, you have seen Iterator in a previous class, I expect. What is an iterator? An iterator is related to collections. You could have a collection stored as a list or as a set in a queue, in a stack, in a tree, and so on. So collections are objects that store other objects. So here are some of the data structures that I expect you have some experience with: linked lists, queues, stacks. You may not have seen double-ended queues, doesn't matter much. Binary search trees, you certainly should have seen. Some of you might have seen B trees and hash tables. But you should know what a collection is, and you should be, okay? So what is the problem that we are talking about? Suppose we have the implementation of a collection. So let's say person A has implemented a collection, and there is a client C that is using this collection. So this collection is not, the code is not available to us. Somebody has implemented it. We use that class to create our programs. So this client is very happy with the collection. There are some methods that are in the collection class to retrieve the objects that are stored in the collection, to store new objects, delete objects, traverse the objects, and so on. So the client is using all this, everything is going well. But then suddenly the collection designer decides to modify the collection class. That is, change some of the methods, change the way, in particular, how objects are retrieved. If you do that, it is likely that the client will break. The client code no longer works for this new version of the collection. So the client is unhappy. What could go wrong? So what should we do to prevent such bad situations? Let's look at one possible implementation. We are not going to look at all the code or anything. Let's assume that there is an implementation of a list. So I call it list implementation 1, that has, among other things, 2 specific methods. One is size. It returns the number of elements in the list. So if you have 50 elements, this would return 50. And a second method is get. Given an index, it will return the element at that location. So let's assume that we have a zero-based indexing scheme. So you will put 0, 1, 2, 3, etc. to get the successive elements of the list. So one could have a client look like this, coded like this: private list implementation 1. Let's assume that is the class name, elements. And let's assume that there is code to create this object, put stuff into that collection, etc., etc. But let's focus on this particular piece of client code. The client has written this piece of code. For int index equals 0, index less than elements, this is the collection, right? Elements dot size. So if size is 5, this will be 5. Elements dot size would be 5, right? And index plus plus. So you can see that index is incremented here, and assume it is not incremented anywhere else or decremented anywhere else. Then this will iterate 5 times if elements dot size is 5. So this will iterate as many times as elements dot size. And each time we are getting an object from this collection elements by writing elements.get and passing the value of index. And that is the object stored in the collection. We process the object. So things are working fine. Now let's assume the collection designer, the person who wrote list implementation 1, comes up with a new version of that. Perhaps it is list implementation 2, and assume that there is no size method, there is no get method in list implementation 2. So let's assume that list implementation 1 has been deprecated. You are not advised to use it. So the client starts using list, changes this to list implementation 2. But this code is no longer going to work because there is no more get in list implementation 2. There is no size in list implementation 2. On the other hand, there are methods like reset, which would make the collection ready to return elements, and next, that makes it possible to get an element that is not in, that has not yet been looked at. So this is not going to be a happy situation for the client, because the client code is that was there is no longer even compiling. So what is the solution? There is no real magic to this solution. What we do is resort to standards. So what we are going to say is, well, let's have the agreement that every collection will support an iterator. That is, you can ask a collection for an iterator. And the iterator has an interface that we promise will never change. So let's see what the idea is. If you have a collection, let's call it my collection. So that would be like elements here. It is always possible. This is kind of a standard, like to have a method iterator on every collection that anybody creates. So my collection.iterator will return an iterator object. And this iterator object never changes its interface. And you can use that iterator object to retrieve all the elements. So that is the principle. So the iterator design pattern is meant to handle the situation where collections are changed, but the client that handles the collection does not want to be breaking its code. So the iterator is a third object, different from the collection, different from the client. It is something that a client asks a collection for. Every collection is supposed to be delivering an iterator on demand. And that iterator has specific methods that never changes. So two common methods found in iterator are has next and next. We will see the details of this later. The collection has the method iterator that returns the iterator object, and the iterator object has next and next. So these two are part of the iterator design pattern. There is a collection here. That is one of the players. The collection supplies an iterator. That is a second player. A client is there to use the collection. Then we have possible implementations of the collection interface. This is an interface. So there are lots of classes that implement this. And iterator is an interface and a lot of implementations of the iterator. For every collection, there would be a corresponding iterator implementation. So for every collection class, there would be a corresponding iterator class. So how do we use iterator? Before we look at how iterators are implemented, let's see how to use them. We can have this kind of a code in Java. Collection is an interface, is new linked list. Many collections, I suppose probably every one of them in java.util implements this interface. I'm not entirely sure about that, but I suppose most of them would be implementing this collection interface. So new linked list is a specific collection that stores objects in the form of a linked list. And I call it collection. I can add stuff into this collection. I can add a string, I can have an integer, and then I use the collection like this to print out all the elements. I get an iterator from the collection. So I ask the collection, give me your iterator, give me an iterator object. And it is of type iterator. That is the name of the interface in Java. And this gives me the iterator object. I ask the iterator object, do you have an object that I haven't seen before? As long as there is at least one object that I haven't been delivered by this iterator, that hasn't been delivered to me by the iterator, this would be true. So iterator.hasNext would be true if there is at least one element that has not yet been delivered to me. If so, iterator.next will give me one such object, and I can do whatever I want with that. I am simply printing it here. Then I ask again, do you have one more? And if so, I will get that. Then I ask again, and then I use that. I keep going through this until this says, I have given you everything. I don't have anything new. Then the whole loop ends. So even if you change this linked list to array list or a vector or something else, this code here will not break because it is using the iterator interface, and all these collections are supposed to be having the ability to return an iterator object.